15 years ago, I had no idea what electromagnetic fields were. I had no idea there was such a thing as EMF pollution. And if you would have told me then, that I would be here today speaking on this topic, I probably wouldn't have believed you. I wouldn't have known what to say or even where to begin. But back then, something happened that changed everything and ultimately led me to this field of work. Somebody I'm very close to, who happens to be one of our Greenwave founders, became electrically sensitive. He began experiencing a lot of really uncomfortable, unpleasant symptoms, and it didn't take him long to recognize that they seemed to be related to his high EMF exposure. At the time, I admit, I was a bit of a skeptic. I had no idea what EMFs were, let alone that they could affect our health. And that began for me a real process of exploration. I started reading everything I could get my hands on about the different types of EMF, and including studies from around the world that began to show connections between EMF and health problems. And I met a lot of people who seemed to really be suffering as a result of their exposure. And now, 15 years later, after our own personal family journey, as well as just seeing firsthand how many people have been affected by this, I'm more convinced than ever that man-made EMFs are affecting us all, everyone, not just those people who happen to be hypersensitive. When we started Greenwave, there wasn't nearly as much information out there about this topic. And more than anything, we wanted to help educate people about EMFs and health, and also to provide solutions. And now at Greenwave, we believe really strongly that our electromagnetic environment matters to health. Just like eating nutritious foods or exercising or managing stress or being careful of what chemicals we expose ourselves to in personal care products or cleaning products, that cleaning up EMF pollution in our homes and other places is really an important piece of the modern healthy living puzzle. Today I'm going to talk to you about dirty electricity, what it is, how to measure it, and how you can reduce your exposure. Dirty electricity is just one type of EMF. EMF stands for electromagnetic fields. It's also known as electromagnetic radiation, or EMR. Some types of EMF are natural, such as Earth's magnetic field, cosmic rays from space, or even sunlight. And our bodies are very well adapted to these natural types of EMF. In fact, we actually rely on them. But enter humans. Thanks to good old human ingenuity, we're now also exposed to lots of artificial EMF. This exposure started just a little bit over 100 years ago with the introduction of electricity into homes and other buildings. But it's really been in the last 20 to 30 years, very recently, that this artificial EMF has expanded or increased exponentially, mostly due to modern electronics, the wireless revolution, and a strong push for energy efficiency in a lot of areas. It's artificial electromagnetic radiation is now so prevalent, it's often called EMF pollution. When I began learning about all this, I was so surprised, to discover that in really a relatively short period of human history, we have moved from a world in which we were bathed only in natural types of EMF to one in which we're exposed nearly constantly to a wide variety of man-made electromagnetic radiation. In fact, experts now estimate that our exposure to artificial EMF is billions of times higher than natural levels. EMF pollution can be broken into three categories: radio frequency and microwave radiation, mostly from wireless technologies; power frequency electric and magnetic fields from clean AC electricity; and finally, dirty electricity. So dirty electricity is a term that is used to describe surges and spikes of electromagnetic energy that travel along power lines and wires where only conventional, regular, clean AC electricity should be. If you start researching or learning about dirty electricity, you're probably going to see it called by other names: dirty power, electrical noise, line noise, electromagnetic interference, power line EMI, microsurge electrical pollution, and then some technical terms like harmonics and voltage transients. People ask us, well, how is this stuff created? Where does dirty electricity come from? The easiest answer to that is most of it comes from or is produced by electronics, appliances, energy efficient lights, and other devices that run on electricity. And it's actually not a brand new phenomenon, but it has become a big problem over the last probably 20 years, 30 years. Many modern devices no longer use conventional AC electricity kind of as is. Instead, they have to change or manipulate it in one way or another in order to operate. Many devices these days draw power kind of in these little pulses or bits, rather than drawing it as a continuous stream. And they do that by turning the flow of electrical current on and off repeatedly, sometimes thousands of times per second. A lot of devices also have to change conventional, what's called AC electricity, which is alternating current, to DC electricity, which is direct current. And direct current sort of flows continuously or steadily in one direction versus alternating directions periodically like AC electricity does. And then another big change is a lot of devices, or many modern devices, have to reduce the electrical voltage. And voltage, if you're not familiar with what that is basically just the pressure or force that helps push electrical current through a power line or a wire or a power cord. The standard residential voltage in the United States and Canada is usually about 120 volts. In other parts of the world, it's often somewhere between 220 or 240 volts. The problem is most devices today can't run on voltage that high. They have to have much lower voltage. So it's these types of changes and manipulations that I just described that cause a lot of interruptions in that smooth flow of electrical current. And it's these interruptions that cause dirty electricity, or in technical terms, those surges and spikes of current and voltage known as harmonics and voltage transients. The list of equipment and appliances and other devices that create dirty electricity is really long. These days, nearly every electronic and most appliances that we plug in produce dirty electricity. Some of them a lot, some of them, a little, but most of them create it. Some of the biggest offenders in our homes and the other places where we spend a lot of time are things like light dimmer switches, energy efficient lights such as compact fluorescent and LED bulbs, equipment and appliances with motors, especially variable speed motors. Also equipment and appliances with transformers, or what are called switch mode power supplies. Those things are the components in all electronic equipment that are responsible for changing AC electricity to DC or lowering that voltage. Other things are things like smart meters and appliances, solar panels, the list kind of goes on and on. Once dirty electricity is produced by these and other devices, it spreads. Some of it is going to radiate directly off those devices, but even more of it travels throughout a building via the wiring in our walls and our ceilings and our floors. Surprisingly, it's now common for dirty electricity from lots of different sources around a building to be, and at different frequencies even, to be traveling along those building wires simultaneously. You'll find that the dirty electricity is also going to move up and down all of the power cords that we have plugged into our outlets. And as it flows along these cords and also through the wiring in our walls and other places, it's emitting potentially harmful electromagnetic fields, or EMFs, into the rooms and other spaces where people are spending their time. Not only does that dirty electricity travel throughout a building, but it can also move from building to building via power lines and even through the earth. And this is a really important concept or thing to understand because it has an important implication. And we're going to talk about this a little bit more later, but when it comes to reducing sources, even if you were to try and get rid of every single source of dirty electricity in your home or another place where you spend time, it's still likely that you're going to have some or a lot of dirty electricity on the wiring in those buildings because it's able to travel from elsewhere into your building via power lines and those other means I described. This brings us to a really important question, and that's why should we care about dirty electricity? Does it matter that this electrical trash is so prevalent in buildings today? And the answer to those questions is really twofold. First, dirty electricity is damaging to the equipment and infrastructure that our utility companies use to transmit and distribute electricity to towns and neighborhoods and individual buildings. And not only that, but it can also damage appliance and other sensitive electrical devices inside our buildings, both interfering with their ability to function at their best and also oftentimes shortening their lifespan. More important, probably, at least in my mind, are the effects that chronic exposure to dirty electricity can have on our health and bodies. So like other types of EMF pollution, dirty electricity is bioactive. And really what that means is that it can cause adverse effects even down to a cellular level in our body. And these effects can cascade, leading to unpleasant symptoms in the short term and even more serious conditions and health problems over time. Some examples of health issues linked to dirty electricity, both via scientific evidence, but also a lot of anecdotal evidence, include things like cancer, diabetes, headaches, ADHD symptoms, pain, all the types of things that you're seeing listed on your screen right now. Oftentimes customers will call us because they're having particular problems, and once they take action to reduce the dirty electricity in their environment, they oftentimes see big improvements or alleviation of some of their worst or most bothersome symptoms. So before I move on, I want to give a quick shout out to some of the scientists who've done really groundbreaking work on studying dirty electricity and its effects on health. So people like Sam Milham, Magda Havas, Ole Johansson, and others. I just want to say thanks, for helping us learn about, why it's important to pay attention to dirty electricity and other types of EMF. So while more research on dirty electricity is definitely warranted, there really is already ample evidence to suggest that we should exercise the precautionary principle. And really all that means is that while we wait for additional, evidence to confirm connections between dirty electricity and health, it makes sense to measure our exposure and to reduce that exposure if it's higher than is healthy. So there are three main approaches to measuring dirty electricity. The first involves measuring the amount of dirty electricity that's traveling along the wiring in buildings. The second way is to measure what we call ambient dirty electricity, those dirty electricity fields that radiate into the air from wiring or the equipment and appliances that create dirty electricity. The third is to measure effects that dirty electricity exposure can have in the body. So I'd like to take a little bit of time to get into more detail about each of these ways to measure dirty electricity. So let's start with measuring the dirty electricity that's present on building wiring. I described a little bit earlier the dirty electricity that's produced by modern electronics and other devices is conducted back onto our wiring, where it can then travel throughout a building, kind of hopping from one circuit to another. So measuring the dirty electricity that's present on wiring is sort of a good proxy for the dirty electricity fields that are ultimately going to radiate off that wiring. There are two main ways to measure the dirty electricity present or traveling along our wiring. First is with an oscilloscope. Second is with what we call a plug-in EMI meter. An oscilloscope and spectrum analyzer allow you to look at the sine wave of AC electricity as well as the dirty electricity noise simultaneously, kind of on a screen in real time. And with these tools, you can analyze specific characteristics of dirty electricity, including the amplitude or the magnitude of those voltage surges and spikes, as well as the waveform and frequency characteristics of electrical noise. Unfortunately, oscilloscopes and spectrum analyzers can be expensive and they're not simple to use. They require quite a bit of training and expertise, both to use effectively as well as to interpret those results. A much easier and more cost-effective way for most people to measure the dirty electricity flowing along building wires is to use a plug-in EMI meter, also known as a line noise meter or a microsurge meter. Plug-in EMI meters, like the Greenwave meters shown here, are really easy to use. You simply plug them into electrical outlets to measure the level of dirty electricity flowing along nearby wiring. Plug-in meters measure the electric field component of dirty electricity. Greenwave's meter shows dirty electricity readings in millivolts, which is a standard electrical unit of measure. And those readings represent the average magnitude of voltage surges and spikes across a broad frequency range covered by the meter, which is approximately 3 kilohertz all the way up to 10,000 kilohertz or 10 megahertz. When you plug the Greenwave broadband EMI meter into an outlet, the top millivolt reading on the display screen will flash numbers until the average level of dirty electricity at the outlet is calculated. Once this average is calculated, the top millivolt reading will stop flashing. The bottom millivolt reading will continue to flash numbers showing the moment-to-moment fluctuations in dirty electricity on nearby wiring. This is a great feature of the meter because it gives you the ability to show before and after readings on the same screen simultaneously. This can be really useful when you want to measure how much dirty electricity is generated by a particular electronic device, or when gauging the effectiveness of dirty electricity filters and other EMI mitigation strategies. Notice the buzzing sound. Greenwave's meter also includes a special audio feature which converts dirty electricity frequencies into representative audio. This allows you to listen to the electrical noise on your wiring. Let's look at a quick example. Here we're going to use the Greenwave broadband EMI meter to see how much dirty electricity a compact fluorescent light bulb creates on wiring. You can try this experiment with other electronic devices too. First, plug the meter into one outlet of a power strip. Leave the meter plugged into the power strip. Next, plug a compact fluorescent light bulb into another outlet on the same strip. The new level of dirty electricity after plugging in the CFL will appear in millivolts below the original reading on the meter's screen. As you can see by comparing the top and bottom readings, the dirty electricity level goes up after plugging in just one of these energy-efficient light bulbs. Greenwave is very excited to be developing a new, more advanced plug-in EMI meter. Our new spectrum meter will include some of the features of our existing meter, but will also include more advanced features such as touchscreen technology. The meter will allow users to scroll between several screens and to see dirty electricity presented from a couple of different perspectives. Not only will you be able to see the millivolt readings as you see with our broadband EMI meter, but you'll also be able to see waveform characteristics of the dirty electricity, as well as how that dirty electricity is sort of distributed across several frequency bands. The meter is still in its testing phases, but we expect it to be ready for sale by the end of 2020. The second overarching approach to measuring dirty electricity involves measuring ambient dirty electricity fields. As I mentioned previously, dirty electricity that's traveling along your wiring is going to radiate very low frequency electric and magnetic fields out into the air. Those same fields are going to radiate directly off of appliances, equipment, and other devices that actually produce dirty electricity. And it's possible to measure these ambient dirty electricity fields in the air. The most basic way to do this is to use a portable AM radio, like the radio I have here. Basically, you start by just turning on the radio and then tuning it off station to a place where you just hear static. And then you can take the radio and you can sort of walk around your environment. And when the radio is in the presence of dirty electricity fields in the air, it's going to either make a louder buzzing sound, or sometimes you'll just notice a change in the nature of the static. Sometimes it'll be clicking noises or strange interruptions, or like I said, sometimes a louder buzzing sound. Let's see what happens as I get closer to this compact fluorescent light bulb. As we saw previously, compact fluorescent light bulbs are notorious for creating dirty electricity. As we get closer to this light bulb, I start to notice differences in the sound. This time it's not necessarily buzzing more loudly, but we're hearing weird interference with that static. And that's just kind of as a way or an indication that you're in the presence of the fields coming off of that light bulb. So this portable AM radio is a great tool for just detecting the presence of dirty electricity fields in the air, but it's not going to tell you a whole lot or really anything about the strength of those fields. So if you are interested in measuring the strength of ambient dirty electricity fields, you need pretty sophisticated electric field and magnetic field meters. And here's the challenge that we've run into, is that most kind of affordable consumer level electric field meters or Gauss meters aren't very effective for this job. First off, they are not able to measure oftentimes all dirty electricity frequencies. They might be able to measure some, but they don't get some of those higher frequency dirty electricity fields. Second problem is they're not always very sensitive on the lower end, meaning that they're not able to register sort of low-end readings that would still be considered too high of a dirty electricity field, according to experts. And then the third issue, and probably I would say the biggest issue, is that most of these kind of lower-end meters are not able to measure dirty electricity fields separate from just the 50 or 60 hertz fields that you get, magnetic and electric coming off of regular electricity. And so because they can't measure those fields separately, it makes interpreting results difficult. There are professional meters that allow you to measure the ambient dirty electricity fields in the air. This is one that we have. It's the Gigahertz Solution NFA 1000. It's quite an expensive meter, probably because it's able to do a lot. The meter measures both electric and magnetic fields across a very broad frequency range, and from about 5 hertz all the way up to 1 megahertz. And that covers all or nearly all dirty electricity frequencies. More importantly, this particular meter allows you to measure different frequency bands separately. So in other words, it allows you to measure dirty electricity fields separate from 50 or 60 hertz fields of a regular electricity. So it's much more informative in terms of measuring dirty electricity fields than just a consumer level meter would be. The third and final approach to measuring dirty electricity involves measuring how exposure creates effects in your body. Two ways to do this are to measure either body voltage or body amperage in the presence of dirty electricity sources. And what these forms of measurement do is they provide a sense of how dirty electricity fields couple to your body or induce currents at a biological level. This gets pretty technical, and so for the sake of this video, we're not going to get into this in a lot of detail, but keep an eye on our website. We will have more information coming out about these measurement strategies soon. So I know this probably seems like a lot of information about measuring dirty electricity. I've been doing this a long time, so I wanted you to at least know that there are different ways to measure dirty electricity, but as you can see, some of them are complicated and get quite technical. What we've found over time, especially in talking with our customers, is that for most people, The easiest way to measure dirty electricity or to find out how much you have at home or other places you spend time is to measure what's on your wiring and to do it with a plug-in EMI meter. This brings us to what's probably the most important part of this journey, and that's how can we reduce dirty electricity around us to levels, that are reasonable and still lead normal lives. We had to do this as a family, and we've worked with lots of clients to help them do the same. It's kind of become our mission to help people reduce dirty electricity. And what we've found is really it's a combination of two main strategies that are best for taking levels down in the places where you spend time. The first is see what you can do to either eliminate or reduce the actual sources of dirty electricity in your environment, meaning all the equipment, appliances, etc. And second, installing dirty electricity filters to take care of the dirty electricity that still remains on your wiring once you've eliminated some sources. Let's take a look at these strategies in a little bit more detail. Back in 2005, when as a family we began tackling dirty electricity in our own environment, we first spent time just learning about and understanding the different equipment, appliances, and other devices that produce dirty electricity. And we were really surprised to find out just how many of them there are in most buildings. Just looking around our own home, it seemed like so many things that we had plugged in created dirty electricity. And so we began to ask ourselves and ponder several key questions. Which of those dirty electricity sources could we get rid of entirely? Which could we replace with items that didn't produce dirty electricity? And then finally, for those sources that we just couldn't get rid of or weren't willing to, how could we reduce our exposure to the dirty electricity that they created? And so as we thought through this, we came up with an action plan and some concrete steps for how we could eliminate sources or reduce sources in our environment. And while, there's just too many steps to cover right now, I wanted to at least cover some steps that, we've found really helpful, as well as our customers have too. So first one, if you use energy efficient light bulbs like compact fluorescent bulbs, some LED bulbs, low voltage halogen, we strongly recommend replacing those with either traditional incandescent light bulbs or halogen incandescent bulbs, which are halogen bulbs that run at 120 volts. Those types of light bulbs will not create dirty electricity. Second, when you're not using equipment and appliances, turn them off and actually unplug them. It's important to unplug them as well as turning them off, because dirty electricity loves to travel along power cords. So even if a device is off, there may be dirty electricity traveling through the walls, and it will just take a little trip, up those power cords. So we recommend unplugging them, or alternatively, you can plug everything into a power strip that has an on-off button, and then just turn that button off when you're not using the items plugged into the strip. There's always going to be sources of dirty electricity that you can't get rid of or don't want to. So when that's the case, try and create a little space between yourself and those sources. So don't put your bed, or your office chair, or the chair that you sit in to watch TV. Try not to put them, right next to a known source of dirty electricity. If you use a laptop, try to use it in battery mode as much as possible. And if you do use it when it's plugged in, try to ground it, because that'll give dirty electricity a better path, out of your house than, through you. And there's lots of ways to ground computers. I would recommend reading the article Safe Use of Computers by building biologist Orem Miller of Create Healthy Homes. Next is at night, we recommend, or at least considering, turning off electrical circuits that affect your sleeping area. So those can be your bedroom circuits as well as some of the circuits in adjacent rooms. There's a process that you can go through either yourself or with the help of an EMF specialist to identify which combination of circuits is appropriate to turn off and will give you the best results. And then you can either turn those off manually, or there's a really cool kind of device that you can install at your panel that allows you to turn the whole group of identified circuits off just with a click of a button. And once those circuits are turned off, you're not going to get any fields, whether they be dirty electricity, electric fields, or just the 60 hertz fields from regular electricity. None of that's going to be able to kind of radiate off a hot wire if the circuit's turned off. Next thing is dimmer switches. huge source of dirty electricity, we recommend replacing them with regular on-off switches. If you've got, your appliances, your lamps, you can replace those unshielded, Romex cords that they typically come with shielded cords. You may need the help of an electrician. Similarly, if you are remodeling or building a new home, you might want to consider installing shielded wiring in your walls. Again, the great benefit of shielded cords and shielded wiring is that you're not going to get electric fields radiating off of those wires. That's just a few tips. Like I said, there's many, many more, but we just wanted to give you a flavor of some of the things you can do to begin eliminating those sources in your environment. It wasn't long into our own dirty electricity cleanup journey that we realized that we weren't going to be able to eliminate all of the sources in our environment. And even if we could, there would probably still be dirty electricity traveling along our wiring that was coming in from the outside. So we began to explore other alternatives, and we're really excited to discover that this particular type of EMF pollution, dirty electricity, could be filtered. And that began our kind of efforts to develop a line of innovative filters for filtering dirty electricity. What are dirty electricity filters? Basically, they are designed to reduce the level of dirty electricity that's traveling along the wiring in our walls. And they target this, noise on wires. They aren't going to mitigate any fields that radiate, into the air, and they're not going to reduce other types of EMF pollution, such as, wireless radiation or just the regular electric and magnetic fields from electricity. Now, there are two general types of dirty electricity filters I'd like to talk about: whole house filters and plug-in filters. Whole house filters are designed to target the dirty electricity that's coming into a building from the outside. These are also called line noise filters or sometimes line conditioners. And they are typically installed at your circuit breaker panel so that once they're installed, all the electricity coming into your house has to go through the filters first, and it's taken care of before it's then distributed among all of the wiring in your house. So these are great for that purpose. Some of the drawbacks of these particular filters is that they're typically not able to filter the dirty electricity that's created by equipment and appliances inside your house, at least not until that dirty electricity kind of travels all the way back through your wiring to the main panel. They can also be expensive because you often have to have one installed for each of the supply lines coming into your house, and there are 2 of those. And they also have to be installed by a licensed electrician so that it's done properly and safely. The other dirty electricity filter option is plug-in filters, like the Greenwave filter that you're seeing on your screen. Typically, this type of filter is installed directly in electrical outlets throughout an environment. It can also be installed very close to your main electrical panel, and in that way can mimic a whole house system. These filters are great. They're really easy to use. You simply plug them into electrical outlets and they start targeting that dirty electricity riding along your wiring. Most plug-in filters, Greenwave filters included, utilize capacitive technology to reduce the amplitude or magnitude of high-frequency voltage transients. These filters basically short out and then shunt voltage surges and spikes to a circuit's neutral wire by creating reactive current. Our standard Greenwave filters feature a multi-capacitor design, which basically helps the filters to target a broad range of dirty electricity frequencies, from about 6 kilohertz all the way up to 10,000 kilohertz or 10 megahertz. The filters meet rigorous safety and environmental standards. So our filters for the US and Canada are UL approved. In Europe, they are CE and SEMCO approved, and they also meet what are called ROH regulations. And those regulations limit or ban the use of heavy metals and other hazardous materials in the use or in the manufacturing of electronic and electrical equipment. Most Greenwave filters include a great feature that is loved by our customers, and that is a built-in outlet at their base. And basically this is for plug-through convenience. Our filters for the US and Japan come in both 3-prong and 2-prong models so that you have flexibility for installation. And we also have several international filter models available. The newest of those in our filter line are filters for Switzerland, and also filters for many other European countries that have sockets that can accommodate a Schuko plug. I'd like to share just a few key tips and procedures for installing plug-in dirty electricity filters. First is, we typically recommend that you install throughout your environment, and the number of filters you need is going to depend on a number of factors. You know, how big your place is, how much dirty electricity you have. And that leads us to the second really important recommendation, and that is we strongly encourage you to use a plug-in EMI meter like Greenwave's broadband EMI meter to guide installation of your filters. A couple reasons for this. First, it's going to help you see, to begin with, how much dirty electricity you have and where it's the highest. Second is it also helps you identify actual sources of dirty electricity, and this is very important because you want to be installing filters as close to known sources as possible. You don't want dirty electricity to have to travel too far to get to a filter, because as it travels, it's going to be radiating fields into your environment. Third is the meter is great because it can show you just how much dirty electricity your filters are reducing. And this is reassuring for lots of customers who just want to know that their filters are doing the hard work that they need to do. With Greenwave's meter, it's really handy because you're able to see both the before filter and after filter measurements on the same screen simultaneously, so that makes comparisons very easy. Finally, the meter can help you determine the best number, the optimal number of filters to install in a particular room, and it can help you choose which combination of outlets gets you the best result. Before installing plug-in filters, it's important to check for wiring errors. Wiring errors can be an electrical hazard in home, and they can also create high magnetic fields. So magnetic fields are another type of EMF pollution, and they are a problem in and of themselves. They can also be exacerbated when you plug in electrical items, including dirty electricity filters. We suggest holding off on installing filters in outlets where there are known wiring errors. For more information on how to test for wiring errors, check out our website's FAQ section. It's also important to note that plug-in filters can act as a point source of magnetic fields, and that simply means that they're going to emit a very localized magnetic field. You can measure this field with a Gauss meter, and as you can see here, the field will be quite high close to the filter, but it drops off very quickly as you move away from the filter. Typically within 6 to 12 inches, that field is mostly gone. So we recommend beginning the filter installation process by plugging several filters in as close to your main electrical circuit panel as possible. This is going to help you filter that dirty electricity that's coming in from the outside. Once you've done that, then you can start to move around your space from room to room, taking measurements and installing filters as necessary to bring levels down, to around 50 millivolts or less. And those are the levels that we feel, create a nice, clean, healthy environment. We'd like to end by showing you just a quick demonstration video that illustrates Greenwave filters in action and their effectiveness in reducing that dirty electricity traveling along your wires. I'm going to go ahead and plug the meter into the top outlet here, see what our dirty electricity reading level is. You can see that top level shows we're at over 1,000 millivolts at this outlet. I mean, there's quite a bit of dirty electricity that's traveling along the wiring in this part, of this building. So I'm going to go ahead and I'm going to plug a filter, and I'd like to see how far we can get that down by plugging in a Greenwave dirty electricity filter. You can see here that we were able to bring the readings down to just over our 50 millivolts. Our target level is 50 millivolts or lower if we can get it there. So I think what I'm going to do here, because the dirty electricity was so high here to begin with, I'm going to try plugging 2 filters in to see if we can get even a little bit more reduction. I have these 2 filters plugged into an electrical tee, which is a handy way to be able to plug more than one filter into a socket. And by plugging 2 filters in, we were able to get that reading down to just over 30 millivolts, well below our 50 millivolt target. Thanks so much for giving me the opportunity to share this information with you today. I hope that it's been helpful. You may have questions right now, and that's great. Please call us or write or visit our website. We love questions. You know, it leads to answers. And we are just very excited to be part of this growing community and invite you to share this information and help us spread awareness about EMF pollution. Thanks again.